The DSG gearbox today, I was actually studying this stuff, and I put a gear set on this side of the house so I can actually understand what's going on and how this stuff works, and it's quite fascinating. And the reason I'm saying it's fascinating because it's actually very simple. It's genius. You know, I don't like stuff that is overcomplicated, like inside my head. And the genius stuff, especially in the mechanical engineering, is when everything works but is done in a simple way. The simple way usually is the strongest, is the most reliable way to do it. And I find all of this in this DSG gearbox. This is the DQ250. Then you got the 500, which is much bigger, but this is already big and strong. And I say, okay, before I'm gonna tidy up, I want to show you everything. It's not gonna be short because there's quite a lot of talk about it, because there's various stages of control and explaining why this gearbox is good, why they change so quick, and what's the difference between automatic gearbox and the manual gearbox. My phone doesn't have enough batteries, so I'm using Steve's camera, hence the tripod. So I'm just gonna put you here very quick, and I'll explain what's going on here. There's a lever here I removed, obviously, to take the gearbox apart. I didn't have to, didn't knew, but it's off there. So with this lever, what you do, you move this forth and back, and the last bit I want you to see this. It goes down a little, not much, but a little. So this little thing, see, it's like a big teeth, engages directly on your differential ring, which is added and is actually kind of pressed on with the teeth on, so this cannot spin on your differential case. Now this usually is only used on the auto gearboxes. Obviously if you drop that linkage there, that gear there, which is fixed to the gearbox, it cannot move, you lock in your differential. This is a technique used only on auto boxes. This has never been seen on the manual boxes, because it doesn't have to be. So there you go. This is one of the solutions they adapted from the auto gearbox. So now when you put in parking, you know exactly what's happening. Obviously this is less important thing about this gearbox, but let's start from there. This obviously goes in there with that down, and that gear is actually here on around here, and it grabs both of these gears here. Not one of them, both of them. Let me explain in a second. Let me just get this away. So as you can see, around these teeth, these gears, there's nothing around them. They are purely to engage with the differential gear. Now, this is, remember when people say, I don't know if you know, if you hear that DSG gearboxes, they always have, they kind of pre-engage the gears. So both of these shafts spin, you see, but only one of them is actually engaged. You see, I can spin this one, that one doesn't spin, because it spins freely. It's not actually engaged as gears. No, a single gear is engaged or pre-engaged on that shaft or this shaft. Only one of them actually has a drive. But this is how it works. You know, you don't have to disengage one gear and engage another one and drop the clutch. The other gear, which is on a different shaft, one other, it doesn't matter. I don't actually know which one is first, with second, third, and fourth, and sixth, and all the stuff, because I actually haven't looked that far. I don't have a time. I want to rebuild my VR first. It's not important to this explanation. Important is that one is engaged, and the other one, the ones to drop the clutch, it just transmits to this. It's very quick, very immediate. This is where the speed comes from. Not only from this, I'm going to explain later on, but this is the mechanical side of it. As you can see, usually manual gearboxes, they have three main shafts. These, they have four. There's another one here, this one here, which again is very, mechanically is very clever, very good, very strong. I would say these gears are not small. It looks like O2M, if not slightly bigger. What I like about the mechanical stuff about this is the precision and the quality of the build is very high. This is very good, so we like that. Also, I'm gonna go through the hydraulics of this gearbox in a minute, but before I go there, have a look at these nozzles. 1, 2, 3, 4, 5. you have 5 independent nozzles, because your gear set is inside there. These literally go about, I think, from this side here. They're actually engaged and they stay in between the gears and spraying oil on the gears themselves. So the lubrication of this gearbox is amazing. It's very, very good. That's something very, positive. Again, adds to the reliability of these boxes. But also there's another motive. There's another why. I'll get that in a minute. It's simple, but it's quite complicated to explain because it's slightly different than any other gearboxes. So let me go through this. Hydraulics. Right, you know what? Let me explain how we go from electronic control from your lever or from your ECU when the car is in drive mode. How we going to, let me see what you're seeing. There you go. How are we going to manage just from the lever, or when you add positive and negative on your gear shifter, to actually transmit that electronic pulse to mechanical engagement of the gears? Because essentially what changes gears are these shifters here. These shifters that go up and down, because I can't move them all because it's kind of combined. It has to move combined with that one. I don't know which one, but they move up and down. These move up and down, yeah. And what they do is with these forks, if you see, that slides up or down and engages or disengages the gear. So for example, the gear that this is grabbing here, this fork, there's a ring that grabs the gear on the bottom, and that gear is actually disengaged from this gear, which is fixed to the primary shaft. So this shaft is one piece with this. When this fork goes up, if you see, that ring slides on the top and engages with the outer ring. There you go. And now everything spins the inside ring with the primary shaft. If this is down, that gear can spin, or I can hold it freely, and it's completely disengaged from the primary shaft. And you have 4 of these. So obviously there's a combination of whatever they do, which gear you're gonna select. That's not the matter of the discussion. This is how it works, but this works exactly the same for any manual gearbox. Well, on the manual gearbox you have the selector, you have a lever, you have the a gear selector, a stick that you manually select each gear. We don't have this here, so this is what we're trying to get to. How it comes that you just selecting plus or negative and everything happens. Well, it happens half electrically, and then hydraulically. So let me get through this stuff quickly. Well, there you go. Everything happens here. Now this side of the gearbox, it comes completely from automatic control. The gearboxes, any automatic gearbox has something like this. Is the main board. You can call it the main board. This plug is your interface. Now usually you have the ECU, which controls the engine control module, and then you have the TCU, which is transmission control module or unit, TCU unit, something for the ECU. I call it module. Same thing. You can call them whatever you want, but that's the computer that manages the gearbox. In this case, the computer is actually inside here. Hey, let me take a I'll show you. The whole thing comes out. This, I think they call it Mechatronic or something like this. And the computer is the whiteboard over there. This is the whole. This is the brain of it. Electronic side of the brain. Now let's put it back together because we need this inside in order to explain how this works. We're gonna slice it out and show you exactly step by step what's happening when you want to select the gear. This is your interface. So like I say, usually the TCUs are external, and then the TCU with the interface tells the main board, which is controlled by the solenoid. I'm going to explain in a second. what to do, which solenoid to engage. In this case, it's only the communication between the rest of the car, ECU and the gear stick, whatever, to the main computer, which then this computer actually activates and decides what to do. You just requesting an action and the computer decides how to perform that action. The way it does it, so the computer then says, okay, I want to, let's say, first gear. I know the first gear, it will have to be activated. So it sends the signal through those wide wires. I don't know if you can see them. Those wide wires there. I hope you can see something. Let me lower it. There you go. There's wide wires there which connect this board to the computer. Now this board is, let me do it this way, is nothing less than just a circuit, simple electrical circuit, which connects these cables to these pins. And these pins, as you can see, they connected just to the solenoid, and they are very strong. Let me just take it. Now these two pins on the solenoid is a positive and negative. This is nothing else than just a magnet. It's a solenoid in which magnet inside, there is a pin inside, there's a valve, and positive or negative, you know, engaged or disengaged, closes, opens the valve. Now, before I go forward, I want to show you that I really like this board. It's very sturdy, it's very strong, and these pins are very wide. The engagement pins are very wide as well. So the contact here is not only nice and strong, but I don't see it to fail in any way soon. It's very good system. Again, very simple, very reliable, kind of old school. I like old school to be used with the new technology because it's a good combination. You know, good new ideas with the stuff that it works, not overcomplicated, very simple. And this is exactly that. Now these solenoids, we have, I think, 11 of them, various tapes, smaller, bigger, and all that stuff, but they're actually very simple. This is one of them. So this particular one, let's say, goes here, and you hold it with a screw there, and what it does, it literally just opens and closes a valve. Now there are a series of valves here, 1, 2, 3, 4, 5. This one is a long one. They all have their function. But let's say now, again, like I said, through the interface, you're requesting something from the gearbox to do. You're requesting to put the first gear. So the computer says, okay, I have all the parameters. I'm going to explain the data it acquires from inside the ECU, the gearbox. It sends the signal, which is very simple, just electric, not electronic, positive and negative, closes or opens one of these valves, and opens or closes a hydraulic circuit. Now, let's stop there for a second, because when I say the computer inside needs to have a data. Now the data it has, some of the data obviously comes from here, from the interface, because it will probably know the engine speed, the engine load, the power requested, and how quick it needs to shift, how quick the ECU wants it to shift, and then makes decisions. But also it needs to know where are our gears, because as you know which gear you are in at the moment, you want to know, it's like, okay, I'm a second gear, I want to be in first. So this computer is actually essentially doing your job for you. So it needs to know exactly what speed they are, what speed it is, but also which exactly gear it is in. And because this is mechanically much more complicated, not much more, but more complicated than the traditional mechanical gearbox, it requires much more data. So let me show you. You can see, let me just get a tissue. You see these rings here, this one here, and this one here. These are for the sensors. These work like a crankshaft position sensors. They're quite magnetic, so you can read the exact movement of this ring, therefore the speed. And again, it's separated because I can move this, you see, now, without moving this. Even though it looks like it's just on one shaft. It is and it isn't, because this is when it comes to. Because one of these shafts, I think one of these shafts is connected, I believe that one, to one of the clutch pack, which one is inside and the other is outside. I'm going to show you that in a minute. This is the clutch pack. It's not, all right, later on, see, I'm not overcomplicating this stuff. There's two clutches here. There's external one and internal one. This one, I believe, if I'm wrong, it doesn't matter, really, to be honest, is engaged with external clutch pack, and this one is engaged with the internal clutch pack. So you have kind of like a dual mechanism inside. That's what I'm saying, is like you can have a second gear engaged and the first gear engaged at the same time, and the computer decides which one to actually use at the moment by engaging or disengaging one out of the clutch. This set of gears you can see behind the chain, they move, could be first or second gear, whatever. Or this set of gears, you can see if I move this one, the other one doesn't have to move. There you go. The other set of gears, they're moving. So this is the beauty of the mechanical, this is the genius about the mechanical side of it. But again, the computer that's inside there needs to know exactly what's happening. So it knows the speeds of the, let's call it the first mechanical circuit and the second mechanical circuit, or the gear set. But also when it engages, these have to engage, off all of them. You can see these are very magnetic. You can see the bits of metal sticking to it, because this gearbox was not in very great condition, but I'm gonna get it in a second. Mechanically, as this stuff goes, is mint, is very good, which I'm very impressed. This stuff is strong and reliable, so I'm liking this already. However, these are magnetic. You have two of them, one magnet and two magnet, 1 2 1 2 and 1 2. Now these four sets of magnets, which each of them is attached to one set of shifter, corresponds to these sensors here, 1 and 2, and 1 and 2 on the bottom there. Okay, now these sensors these two are actually reading the speed of these two gear sets, like I said before. So you see, just with those 6 sensors, the computer knows the speed of the individual gear set and exactly the position of each individual gear selector, so knows exactly everything was happening there mechanically. It's very simple, very clever, and again, clever because it's not very complicated. It's a simple way to build, a simple way to maintain, a simple way to engage and disengage, and having control of what's happening there, and telling the computer what's what, and then computer obviously makes a decision of what you're requesting. Because if you stay in 6th gear, you're requesting to be in the first. On the manual gearbox, when you control, you can do it. Obviously, you're gonna grenade the gearbox and the engine, all the stuff. In this case, the intelligent computer will say, well, sweetheart, we cannot do that, because I know what I'm gonna do, and this isn't it. So that's obviously the data the computer requires before executing what you're requesting it from it to do. Now, let's go ahead here. I'm gonna put you back on the tripod. Oh, this is funny. Sorry, let me just check what you're seeing. Yeah, it'll be fine. So let's take this brain apart slowly. Like we say, this is the electronics, which is behind there, communicates through this board, and then through the solenoids with just positive and negative signals, closes or opens the circuits inside this board. So let's open this board and have a look inside. Is built in 2 parts, actually in this case 3 parts, but mechanically hydraulic in 2 parts. So this is one part. Behind looks like this. It looks identical to any other automatic gearbox. You have a gasket here, there's a screw to keep obviously all the stuff inside, and there's a lot of different oil passages, small, big ones, one-way valves, obviously having to get apart. But then I guess you can, if you take this plate off, you can take these off and take these valves apart. Do you know what? For the sake of curiosity, why not? Give me a second. Let me take this screw off. Let's see if we can take one out. go. So let's take the screw out. I'm not sure if there are any other or not. I haven't took this apart yet. This is literally today I'm installing this gearbox, and I like it. I don't like who walked on it as a cowboy, but let's see. There you go. This should come apart. There's a gasket. You see all the galleries, all the oil galleries and passages, and you can see there are springs inside. I don't know if you can spot them. There's 2 springs there. There's different valves there. Actually, if I take maybe that valve there, I have to push it. You see there's a spring there, so I have to push that piston to remove this pin. Let me see if I can do it for you quickly. Yes, there you go. So, I'm not sure if I'll be able to move it for you. You see? There you go. This is a valve, and this is one oil passage, this is another one, this is another one, this is another one, and I guess that's another one. Depending on which position it is, opens or closes different oil passages. And this is only mechanical, this is just spring loaded, but obviously depending on where the oil pressure goes, for example, if it goes from the top here, from the top, it may push it down. It's quite complicated. This is why to work on the auto gearbox you have to be a specialist, because this stuff, this here is complicated. Obviously again it's only complicated because you don't know how it works. Once you know how it works, like any other specialist is going to tell you it's simple. Again, knowledge is the key. I don't actually know. I know the principles, but not exactly what goes what. But it's very clever, and actually it's simple. So this is part of it. There's a gasket, and also this. And then you can see once, wow, where's this going? I don't remember. There you go. Once you cover this, all those passages on this side of the boat are covered, and it communicates through the fluid, through the high pressure oil, to this side of the valve, or the valve boat, main boat, if you want to call it so, hydraulic one, through these small holes. Okay, these small holes again then correspond to this side, which will be somewhere, how will this go? I guess that way. There you go. See? It will only correspond to some of the oil galleries, not all of them, right? I guess I should take it apart to show you better. Oh, where are you going? There you go. We take the electrical power side, you know, communicates with all this side with this, but once you remove it, you discover that inside there are a series of all the oil galleries. There are small air filters. This is an oil filter. You see how tiny it is? And there's plenty of them. 2 already are gone somewhere. There are some other valves here, I guess one-way valves, you know, electrical contacts for more sensors and all that stuff. This is your boat. On the other side is your ECU. Now this doesn't have to be here. This is just purely by design, by convenience, because it's conveniently compact, and that's it. And then obviously short wires to this side, and this controls the solenoids, which then eventually controls which gallery is open and which one is closed. But essentially what happens is this stays this way. Essentially what happens, let me put it back together because this is very important. I'll show you. Let me get the camera off with the oily hands, as usual. Essentially what happens is all of this board is you control, but this control then now we have it hydraulic control, because again, this is oil solenoid control. The oil galleries, oil has the passages, and then you have the oil pressure, because everything works with oil pressure. You're gonna get that in a second, how this happens. All of this has to be transmitted to the movement of these, right, of the gear selectors, because that's how it works. So all this oil, essentially at the end, you see this is separate from this. You see these oil galleries here? These are part of the gearbox. This is the main board, this is the computer, this is the control, this is the brain. Half hydraulic, half, or I say a third hydraulic, third electric, and a third electronic. The gasket covers all of it, because the board I've shown you before please, goes on top of everything. Not only on this main board, but also on this side, goes on the top of the gearbox. Why? Well, because if you're controlling everything first electronically, then electrically, then hydraulically, so we're using the oil pressures to go inside the gearbox, control this. So it goes inside the gearbox housing. Okay, so let's go and explain that side. It goes from there. As you can see, these galleries here, they correspond to what we've seen from that side. These galleries actually go all the way down there, and on this side, because again this is the other side of the gearbox casing, this is a place for this gasket. So these oil galleries go from inside there and goes both way, this way and that way. On this way, you can see them, they've been drilled inside the housing, and then you have like a pinballs here to close the housing. So this oil gallery here, for example, goes inside there, through this oil gallery, goes inside there. Exactly the same, which is the one I've shown you, this one, is actually this one here, goes all the way down there, and then eventually goes into that. Now that is a piston, is a hydraulic piston. Nothing less than a hydraulic piston. Let me grab a light, see if you can see it. See inside there? You can push them inside, you can't pull them because I need some pressure to pull them out. It's just a normal piston, hydraulic piston. And the beauty is we have one here and one here. That one, when the gearbox is closed, is actually on top of this selector. So this selector is moved by these hydraulic pistons. So again, first gear happens. You tell it from the interface to your computer, which is behind there, I want a first gear. Collects the data through the sensors, which collaborates with these points. The computer knows everything. It's like, okay, no problems, I can select the first gear. It's gonna send a signal, which is only electrical signal plus and minus through these wires to this board. Let's say, just for the sake of argument, to these two pins. This opens a valve inside there. Again, through this board or the oil passages, through the gasket, as is gonna be, let's say again, is gonna push oil there. Probably not, of course not, but the principle of working is exactly the same. When that pressure, they opens a circuit and is gonna push oil here. But that oil is gonna go over there, pushing this one, but releasing the pressure from this one. So this is gonna go up, yeah, or down from both sides, up and down. Very, very simple. Genius. Again, genius is not because it's something new, but it's because it's something old. Hydraulic pistons has been used for decades. We have a lot of data, we know pretty much all about them. So there is nothing new that we have to invent. And this is why it's genius, because it's simple, it's a technology we all know already, we don't have to guess, we have the data, we can make it strong, reliable, and working exactly the way we want it. The beauty is also, as you can see, there's like a ball bearing. This actually is a ball, well, slider to say so, because this is the movement, and you have this balls here. So this is very precise. Once inside, you can see once inside the housing there, it's very precise. good movement. But also in additional, just so we don't rely just on a hydraulic movement, because it is strong, it should be fairly precise. But these gears, as you can see here, for example, the position of this fork really has to be precise to engage everything, especially when you have 6 gears, 2 sets of gears actually separated, packed in a small space. So you can see these recessed, or whatever you call them, I don't know exactly. These are found on any other manual gearbox, and these correspond to these small balls there. Behind that ball there is a spring, so they are spring loaded. If I can push it, very strong. There you go, I can push a little bit. So that one obviously selects, if you move it from here to there, for example, the central part, is gonna keep that selector exactly in that position. It's not gonna move. It's gonna centralize it in exactly the position they want it to be. So it's combined the hydraulic movement, hydraulic control of the movement of the selector with the mechanical stop or controller. So nothing is gonna move. Again, adds to reliability, to the precision of the gearbox, to the quickness of the gearbox, you know, and all the stuff. That's really good. I'm very impressed. Now you say, okay, where all this hydraulic oil and this pressure comes from? All right, so imagine this is the top of the gearbox, this is the bottom of the gearbox. So imagine this as an engine. So this is your sump, the bottom of it. This is your pickup. Let me take it out. Now this pickup gets the oil from the very bottom. So if your car is going left or right, acceleration or deceleration, the oil is going to slush left and down, but on the bottom there's always going to be a reserve of oil. That's why you have the pickup sumps. This pickup sump gets the oil from here. There's a paper filter, this is one use only. On additional here you have these magnets, you see, very dirty, and they pick up all this sludge, all these metals, you know, because from grinding of the gears, it's gonna go up in a second. From grinding of the gears, you see there's a bit of gears usage there. Some of the material is gonna be taken out, and this is it, you know. But this material sticking out to this magnet is not a problem. This material sticking out to this magnet, again, isn't a problem. The problem will be if this material, this metal particles, goes inside the oil galleries. Because as you can see, everything is very small. You know, these passages, they're very small, these valves are very small, some of them they have very small restrictions. That's why you have filters everywhere to protect all this valve body, all this hydraulic brain, to say so, from these metal particles. Also very important, there's a high pressure pump, and the high pressure pump is behind there. And again, high pressure pump only works when it's precise. Now let's slide this back on, and we're gonna see how this oil goes to this valve body. We got the oil picking up from the sump through this pickup, magnets, filter. So clean oil goes through there, this is all plastic passages there, and it goes to the other side of the gearbox. So let's see what's on the side of the gearbox. I'm gonna put the camera here because I need 2 hands to explain. It's gonna be actually better. 2 hands. There you go. I want to see what's going on here as well. Come on, there you go. All right. So obviously I took this apart already. So just one screw, so it doesn't fall off. There's a few of them. This is your Biffy hydraulic high pressure pump. It's cast steel. There is gear driven. So if you see inside there, we can you see it? We can spin it even with a screwdriver. When I spin that, what's happening inside? Oh, besides the fact that this gearbox doesn't have any shaft, so this will station up. Besides, someone actually messed with this, and as you can see, scratched it, and you know, bollocks to it. I don't know who worked on it, but again, there's supposed to be a shaft from the primary shaft, which is this one here, to this one. I think it's that one. To this one. There was nothing there when I took it apart, so this was never working when I put it back together. Also, I'm gonna show you what's inside, but that's a secondary issue. So let's have a look what's inside this pump. Once you take the cover off, remember this is the pickup, and these two sends the oil, high pressure oil. Yeah, picks the oil from this bolt. So here, and it goes inside there. So kind of like behind these gears on the bottom, and through these gears, this pump spins like any other gear-driven pump. Okay, and then through this gallery here, because this is this way, so the oil, okay, see this way, you can see, yeah, so through here goes in there, 1 and 2, and sends the high pressure oil from these holes. This is what happens, but it's very crucial that the surface of these gears, obviously, they are nice and clean, because if there's scratches here, you're gonna have oil going through the scratches instead of through these holes. How the pump is designed, some of the oil is gonna escape from these scratches, and you're gonna lose pressure. And some very intelligent, I don't know who, put a mark on this with a screwdriver, deliberately scratching this. All you have to do is put a marker pen mark. But again, like I say, cowboys. So when you think that I see in majority, I would can say easily majority of the mechanical failures, or the mechanical failures, either the engines or the gearboxes. I need to see. No, it's cool. I can see myself. Not a pretty face, but I can actually see what you're seeing. Majority of the mechanical issues to the gearboxes, automatic gearboxes, engines, differentials, cars in total, maintenance, turbo systems, cooling systems, vacuums, one-way valves, EGR stuff. EGR is crap. That's supposed to be taken away prior to any jobs. But all failures in all those systems, majority of them comes from, first of all, poor maintenance, and second of all, from bad mechanics, to say this way, or people who work on this stuff without having a clue what to do. And you don't actually have to be a qualified mechanic to work on a gearbox like this, because if you actually open it slowly and you study it slowly, everything makes sense. And when stuff makes sense, it's simple. You can actually trace how this works. And even if you never took one apart, you take it apart, you study, you understand that you can put it back together without faults. But you have to be clean, you have to be precise. You can't smash stuff around with the hammer, especially the precision stuff, and scratching the stuff that's supposed to be very precise, and forgetting bits inside and hoping for the best. Not gonna work. Mechanics are ice cold. They do not forgive. If you're doing something wrong, you're gonna pay the consequences. And the problem with people is that they don't want to admit they've been wrong. This is our nature. And from that problem that we don't want to admit that we've done something wrong, even if you have the doubt, I will work without that washer, it'll be fine. It's not gonna be fine. When it's gonna break, it's like, oh, it's a piece of shit. No, it's not a piece of shit. Your brain is a piece of shit. Simple as this. There's no way around it. I've been doing this job for way over 25 years now. Trust me, I learned my lessons. This is how it works. All right? So, besides all of that, I think we covered how this stuff works. Now, all this, obviously, the gearbox now relies on the clean oil, like I said before. Let me move the camera here. So, maintenance. I think they take something like 5 or 7 years of oil, something ridiculous, like an engine. But also there is a reason for that, because everything relies on high pressure oil. The oil has to be good quality, has to be clean. It has to have very high point of boiling. Excuse me. The sensors, the internals and everything is, again, sensitive. I mean, this stuff is quite resistant to temperature, but everything has the limit. So if you overheat the oil, stuff is not going to work. And automatic gearboxes, for example, they're very known for failing when you overheat the oil because of the electrical systems inside. This stuff, although it looks very strong, but again, I wouldn't abuse it just because it's strong. Because it's strong, you know it's going to last you for a long time. Take care of it, you know, as much as possible. So change the oil. So there's not going to be all of this inside the gearbox. This is very bad. You know, change that filter. I know it's expensive, but the oil and the filter is cheaper than the gearbox. And then if you let someone like this work on your gearbox because it's broken, hey, this end up in a scrapper for a reason. Now, so we have a lot of oil, good quality oil, all that stuff is important. Then you have the oil, additional oil filter here. You see all these passages here. Now this passage I explained before, these, I don't know if I explained that before or not. If I didn't, let me do it again. I'm sorry if I'm repeating myself, but I need to be sure. So these oil passages here, beside obviously, so that, again, the high pressure oil pump has two passages, one and another. And I'm guessing the other one is less pressure, or maybe just dedicated for the lubrication of the gearbox. So besides the oil, besides lubricating the gear sets and all the stuff, also they've built these passages here. Now besides this sending the oil through the additional oil filter, like on the engine, which is very good, and through the oil cooler, this is oil heat exchanger. So oil goes from one side to the other, goes through here, there are veins inside, and these veins are filled with water. This essentially works pretty much like our, oh, it's not here. Where did I put my, I don't know where I put it. I put the charge cooler somewhere, I don't know where I put it. I'm a moron. Too much mess in the workshop. Anyways, it works like a heat exchanger, so it's like a charge cooler. Charge cooler, we get in air inside, it's filled with water, cold water. It cools the air, goes through the other side, from the charge cooler to the plenum. This works exactly the same. We got cold water filled inside, hot oil goes in through these veins, cools down, gets out, cooler. Now, the beauty of this is like all these passages, and it has these small nozzles, 1, 2, 3, 4, 5 nozzles. And these, when the gear says it's inside here, you can imagine all the gears are here. These are literally from this side, inside, in between these gears, in these small spaces, spraying oil directly on the gears, on the selectors, on the forks, all the critical points. I've never seen this in any other manual gearboxes. This adds hugely to the reliability of the gearbox. But again, it all relies on a good quality oil and also on a good state of that oil. If that oil is obviously old, not good anymore, it's not gonna work. Also, I'm guessing that you have to cool it a bit more. You spray a bit more oil straight into that, is because the oil used in this gearbox is different than the oil we use in the manual gearboxes. Manual gearboxes oils are usually 75, 80. You can get up to 140. It's very thick and dense oils. Now those oils are not very suitable to compress them through the high pressure pumps. They're not very responsive to the valves. They don't like to go through all the solenoids and the valves. Therefore, the oil here is very thin, it's more watery. But those more watery oils, they're much harder to compress. Therefore, we have much more precision. There is less of a spongy effect. Because if you imagine you have to move these selectors through these hydraulic pistons. If they're gonna act a bit spongy, it's gonna be very vague, the movement, against very thin oil, which is very precise, because it doesn't compress as much, it's less spongy. So that's one of the sides. Also, it's less prone to emulsion, because the thick oil between the gears kind of boils when you mix it very quickly. It makes is it like a starvation stuff, it makes air bubbles. A thinner oil doesn't have that effect as much. So there you go. That's why these gearboxes are so kind of, let's say, fragile or sensitive of the quality of the oil. So it has to be fresh and good and not overheated, hence this. Now on my M2, because I'm using actually one of these gearboxes where the fresh one is coming down, hopefully it's a fresh, again is from a broken car, but hopefully it's good. I'm gonna remove the heat exchanger and I'm gonna put a proper oil cooler, which is gonna be more reliable and it's gonna cool the oil even better. Plus we're gonna use we're gonna have a hard use of that gearbox, so you know we compensate with, you know, we asking for the gearbox to work harder, so we're gonna compensate with giving it a better oil, cooler oil. So external oil cooler instead of heat exchanger, because heat exchangers never work as good as the proper coolers. I think this is it. No, the clutch, the beauty of the clutch. Yeah, this is not ending. Before 3 days of video, which is already recording, is ended. No. We're gonna have the clutch setup. This is a beauty. Now this clutch setup actually comes from the motorcycles assay technology. Not only motorcycles, something dropped the sensor. There's not a sensor here. This is the external one. I think this is speed sensor, but I could be wrong. I don't care. Who cares? This goes to scrap. Now, like I said, there is 2 sets of. Can you see it this way? Yeah, you can see it. 2 sets of clutches here. There's external one and internal one. Now there is a shaft here, a small one, and there's a shaft. You won't be able to see it. It goes from the side there. So they actually separate, like I said before. One of the sets engages probably this one, and the other one engages the one on the top. One shaft split in 2. Very clever, very nice. So let's say that we're gonna take this apart. Okay, so this is internal clutch. This is it of the internal clutch. I can put it back together now. This is one cover for the internal clutch, and this is the cover for the external clutch. Internal, external, they're both internal and they work in a bath of oil. And before I continue, this is having a clutch inside of the oil adds to the importance of having a good oil, because the clutches, when they're gonna be used, because again it's a friction material, they get used. The friction material essentially is gonna get loose and kind of like grinding off, and all the particles of the clutch is gonna go inside the oil. So that's why you have 2 filters. You want to filter those particles. They're not good for anything. So let's take, maybe if I can, I don't want to flip it upside down because everything's gonna come apart, but I think I will have to, or maybe inside. This one's coming off. So you have a metal disc, and then you have your friction disc, which is like your brake pads. You see? And then you have another metal disc, another one of this, another one of this, another one of this. It's a multi-layer. I don't know how many discs we have, but it's a multi-disc wet clutch, means works inside the oil. This is exactly how the motorcycle's clutches work. Obviously motorcycle clutches only have 1 set, not 2, but it's exactly the same technology. And this is what I said before. The wet clutch technology existed already decades ago, so this is nothing new. This is something that we already have a lot of knowledge about it again, and this is why this is genius. Now I have to flip it. I'm sorry. So this is, so this one here inside, it will drive, well, it doesn't want this way, I can't spin it. So this is one drive, you see the splines, and this bollocks. Flip them out. There you go. There you go. Inner clutches. See, multi-disc. and the outer clutches. Again, multi-disc, same, exactly the same, just different diameters, so we have them compact in one basket. This is a clutch basket, it's called motorcycle stuff. So, as you can see, like I said, this works with the inner, and this works with the outer clutches, right? This has larger splines, this has smaller splines, and I really don't want to do it because I'm worried to flip all these gears around, and I really don't want to do it, but I think at this point we should. Please don't fall. Heavy this stuff is. Let's do it gently, maybe it's gonna stay like this. Okay. Now for this, I'm gonna take the camera off again and I'll show you. So this is your input shaft from, this is your motion from the engine side. This is where your flywheel goes attached. There's a missing part, but it doesn't matter. What matters is that we have a motion to this shaft, the inner one, through this one here. I'm gonna move it. See what happens. That gear set, this set of gears is moving. Yeah, remember this? I'm gonna remove it now. I'm gonna show you what happens if I put this one, which was inside, so the smaller set of clutches, goes on the outer side of the shaft. Yeah. It comes apart. But you can see the other stuff it moves. Bollocks. You get the idea. This is exactly what I wanted to avoid, but that was a very long shot. So let me get the camera off a little bit. All the oily hands. I need to save it, I need to put it back together. Bollocks. I really didn't want it to come off. Oh well. That's my coffee table broken. I will have to put it back together. Now at least you can see these selectors, how they work. You see, these are the forks. They go inside the ring and they slide it. I can't slide it forward now. See, they go forth and back. I can't do it with one hand, sorry. Forth and back and engage or disengage all the gears. There you go, you see? Something like that. Now I want to put it back together because this is my new coffee table. The balls of this flying out. I have a few of them. Maybe I can catch them. Again, even if this is completely in bits, if you have any mechanical knowledge, you'll be able to put it apart. Even these balls fly apart, doesn't matter. This is the plastic retainer. Push them in. Push them in. And there you go. And there's the, like I said, hydraulic pistons moving this up and down on these roller slides. This tells the sense of the position of this, and everything works just brilliantly, very good, you know. Obviously I don't think I'm gonna find in this mess the other four balls. It doesn't matter because it doesn't have to be functional at this point. At this point I just want to kind of have it on display because I like it, and that's it. Maybe keep it on the spare. I'm gonna keep the differential. There's one thing to say. This is besides how this gearbox works. When we do our MR2 conversions, we give the adapter plates. So all conversions works only with forward drive gearboxes because we need the transfer case, bolts and pattern for our rear gearbox mount on the chassis. But what happens when you remove the transfer case out of the gearbox, you cannot use the same drive half shaft because it's that long. You need to use a shorter half shaft, one of these. And if you can see, so this is the DSG half shaft, this is the left side, this is the right side. This is not the DSG half shaft. However, if you see the way they built, they're exactly the same. So what I'm saying is, once you move the transfer case, your DSG four-wheel drive gearbox half shaft is probably the long, roughly. You have to use one of these. This is the one from front-wheel drive O2M gearbox. And it happens that Volkswagen doesn't change stuff that works, and it doesn't have to be changed, which is very advantageous for us, because this is the side of the transfer case. Once you remove the collar, you can probably see it from there. Once you remove the collar, okay, this is the gearbox, blah blah, this goes inside and it slides in the spline there. The length of the spline, the length of the half shaft, the width, all the measurement is exactly the same. They haven't changed, which is great because we can use O2M half shafts for the DSG four-wheel drive gearboxes to convert them to rear-wheel drive, in our case, MR2s. And then you put the standard bolt through there and you sort it with our adapter plate. This is very good, obviously. The bad point of this differential is that if you want to put an LSD, or actually I think they make Towson differentials, they are 13 or 1500 pounds, quite a lot. I think on this case, on mine, there's gonna be a quick spool, or to say welded. I will see about that. It's too early to speculate what kind of differential I'm gonna use on my DSG. For now, it's time to build my VR5 engine, because the head gasket, like I said, has arrived. Victor Heinz, there you go. And it's a thicker one. I don't remember what thickness this is, but it lowers the compression to 9.1 to 1, but then with the head work I've done, I'm sure we're gonna be just below 9. It's gonna be 8.8 or 8.9, something like this. Doesn't matter exactly. This is not, 1000 horsepower engine. It's gonna be more than fine. I hope you enjoyed it. This very long video. If you find this stuff fascinating as I do, you probably did, you will have much more fun actually doing it yourself than I did, instead of watching the video. Ooh. Why would you look at that? Do you know what? Shame someone actually worked on this gearbox so poorly, because I'll be having an awesome amount of fun cleaning all of this and putting this gearbox back together the way it's supposed to be, because I'm pretty sure this gearbox works just fine if you do a proper job. And to say so, if you have any problems with the DSG gearbox, I am pretty sure that 99% of issues come from these solenoids. This is the only thing that could go wrong, because this is very typical to go wrong with the automatic gearboxes. And mechanically inside, I really don't see anything that can actually break on its own. Of course, everything could have mechanical failures, but the way they designed this is very strong and is very simple, although it may look difficult or complicated because it's packed with technology. But the technology has been used in a very smart way, which is something that we don't see these days. We see the technology today being used in a very complicated, overcomplicated stuff. The new cars today, they, ridiculously complicated and difficult to fix, to avoid you to fix them. This is the opposite. This is new technology with well-proven, known solutions that we used for many, many years. So, and everything is high quality, looks good stuff, looks built to last, which these days we don't see that often. I like it. Yeah, I think I've done a good decision, and now, only now, I'm actually glad I went DSG with my VR5 setup. You know, I wanted to do this, so I was able to understand and know more about the DSGs before the customers ask the questions. I'm gonna have a experience, mechanical experience and knowledge to educate them or to answer the questions. This is where we start, and I like what I'm seeing. I had a great fun taking it apart. Shema can put it together, but we're gonna build the VR5 now. Anyway, hope you enjoyed it. See you soon.